Thank you, Eric. So I'm going to be telling you all about a couple of things that we're working on in the lab to try to find new and better metformins, to try to gain a deeper understanding of how aging is regulated with the goal of developing therapeutics. And then I'll give you a geriatrician's perspective on how we might use those therapeutics to, well, hopefully to disrupt the practice of medicine and to improve the lives of millions of people. But first, I'll tell you about one person in particular, my grandma, Nan. So when Nan was a spry young 80-year-old, she took care of her garden all by herself, walking around, bending over, pulling the weeds, planting the eggplant, harvesting the rutabagas, all by herself. And then in what seemed like the blink of an eye, suddenly she couldn't do it anymore. And this is something that's familiar to many of you through your parents and your grandparents. Why not? And it wasn't just the arthritis in her fingers. It wasn't just that she was losing sensation from neuropathy. It wasn't just the osteoporotic fractures in her back. It wasn't just the sciatic pain. It wasn't just the frailty and the weakness. It wasn't just any of these things, but it was the combination of all of them together that pushed her past a tipping point where she could no longer do something that she really enjoyed. She had functional decline, as a geriatrician would say, and often that leads to loss of independence. This combination of factors, as Eric alluded to, diseases of aging tend to go together. You get many of them at the same time. Another example of this, heart failure, is a common medical problem among older adults that often contributes to functional decline. But it's never just the heart failure. It turns out that 99% of older adults with heart failure have other chronic diseases too, often many of them, 4, 6, a dozen or more. How do you help people like this? Well, you could try to whack every mole. You could try to treat all of their 12 chronic diseases as powerfully as you can. But in reality, when you try to do that, you often wind up doing more harm than good. The art of being a geriatrician, in large part, is about trying to identify what is the one really important problem that if I focus on that and try to fix that, I'll improve the whole person. But what if, it'd still be nice if there were a better way. Therapies targeted at aging might offer that better way. If aging is the common risk factor for many of these chronic diseases, whose effects together add up to functional decline, loss of independence, well, maybe by targeting aging, we can delay or prevent or at least ameliorate many of those diseases simultaneously and so have an outsized effect on a person's function. That's multimorbidity, addressing multimorbidity, and that's one clinical strategy for using therapies developed from aging. So from there, I'll step into the lab for a minute and give you describe a couple ways in which we're trying to develop new therapeutics, and then I'll close by going back to Nan. So Eric mentioned a couple of really astounding things that I still find really cool, that aging is regulated, and that the pathways and the interventions that can regulate aging are often shared in common across the tree of life, across evolution, from worms and flies to mice and us. Now, one of those common interventions is dietary restriction, or fasting. Fortunately for us, especially with the nice reception I think we have planned afterwards, the benefits of dietary restriction we're learning more and more are not about eating less, per se, but rather eating less is a powerful biological signal that turns on lots of downstream pathways. And these downstream pathways, in turn, implement, so to speak, the health benefits of fasting and dietary restriction. So if we can understand those downstream pathways, we can design therapeutics that will capture some of that benefit. So we work on two particular examples of this. One is a group of enzymes called Sirtuins. Sirtuins are really interesting enzymes that sense the metabolic state inside of your cells as it reflects the metabolic state of your body. And since sirtuins are enzymes, then they go on to modify lots of other proteins and have a bunch of effects throughout your cell. And two of those effects are to help your mitochondria work more efficiently and also to reprogram your gene expression, epigenetic regulation of your genes. Another thing we work on in the lab, similarly, are molecules called ketone bodies. So these are molecules that you make in your own bodies from your fat cells. And if you're exercising or if you're fasting, they help to supply energy to the rest of your body in place of sugar. So that sounds pretty boring. They're just carriers of energy. But Eric's lab found out a couple years ago that they're actually signals too. They're natural drugs, so to speak, that inhibit a group of enzymes called histone deacetylases. These histone deacetylases also regulate epigenetically your gene expression. They turn genes on and off in certain circumstances. So both sirtuins and ketone bodies are examples of this broad idea of how signals from the environment, like what and how you're eating, can reach into your cells and epigenetically regulate gene expression to control your health and control aging. So our hope is that by gaining a deep understanding of how these things work at the molecular level, what genes are being turned on and off, how, in what circumstances, and what tissues, we can intelligently design therapeutics that will capture some of that health benefit and then give it to people who need it, people like my nan. So I already told you one circumstance in which this is being explored clinically for treatment of multimorbidity. Briefly, I'll introduce you to another idea, a related one, that of resilience. So when I'm in the hospital, one of the starkest differences between a 40-year-old and a 92-year-old, like Nan is now, is that when everything goes well for a 40-year-old, they walk out the door and go home. When everything goes really well for a 92-year-old, they're still probably going to be wheeled out to a nursing home, at least temporarily, if not more. It turns out that half of disability in older adults is associated with hospitalizations, even when things go really well. And why is that? Just like with Nan not being able to garden, it's never just one thing, but it's a combination of many different factors, many of which, for which aging is the underlying risk. Losing muscle more quickly when you're immobile, not gaining that muscle back as fast when you're rehabilitating, getting confused, cognitive impairment worsening, lots of different things. And the hope is that therapies targeted at aging will address many of those simultaneously and boost the resilience of older adults to make it more likely that they'll emerge from the hospital in as good a shape as they were before they got sick, or at least that they'll be able to rehabilitate better and get back to where they were faster. So these are two scenarios, treatment of multimorbidity and improving resilience to overcome acute medical problems, for which interventions that target aging are actually in clinical trials right now, or the clinical trials are being designed, including using metformin and another drug called rapamycin. So this is a very exciting time to be in the field of aging research, and a very exciting time at Gladstone. We're in the center of it. And with that, I'll pass the microphone to Shomi, who will tell you about, in much more detail, about one particular system of the body that's profoundly affected by aging, and that is our immune system.